Okay, let's start our chapter electromagnetism or magnetic effect of electric current. Electromagnetism or magnetic effect of electric current. So as we know, as you learned, electric current shows some effects. 3 effects we already know. They are, what are the effects shown by electric current? Is one of the effects of electric current. Effects of electric current. In previous chapter, means in electrical chapter, you learnt heating effect of electric current or something. You already learned in the chapter electricity or electric current, heating effect. Then the second one, chemical effects. Chemical effects of electric current. Chemical effects of electric current. You learn in class 8. You learn in class 8 chemical effects of electric current. Chemical effects of electric current or the chapter electric conductivity of liquids. Electric conductivity of liquids. So in class 8 you learn the chemical effects of electric current. Means what happened when electric current is passed through a conducting solution. That conducting solution we called electrolyte. What happened when electric current is passes through electrolyte? Electrolyte is associated into ions. These ions are carrying conductor and show some effects. What are the chemical effects you learned? So you observe that some gas bubbles are formed. Gas bubbles are formed near the electrodes. Gas bubbles are formed near the electrodes, and there is a change in the color of the solution. There is a change in the color of the solution. So you understand, when electric current is passes to the potato, a greenish blue spot is formed around the positive terminal wire, and a metal is deposited. A metal is deposited over the another. The process is being called as electroplating. So these are the chemical effects you study and you learn in class. Then coming to the third effect is magnetic effect. Magnetic effect of electric current. Magnetic effect of electric current. What happens when electricity or electric current is passed through a current carrying conductor? What are the effects we have got? So that effect is called as magnetic effect. We know heating effect of electric current. When electric current is passes the conductor, due to electric current some heat energy is produced. Such effect we can call as heating effect. You already learned in the chapter electricity, and we can learn some problems also. Chemical effects you learn in class 8. Then magnetic effect of electric current. So magnetic effect of electric current. So previously means previously in the sense. Generally, earlier, before 1820, all are thought that, all are believed that, all are believed that there is no interconnection, there is no connection between electricity and magnetism. Electricity and magnetism. Magnetism is studying about the magnets, what is magnet properties. So whatever related to the magnets. Earlier means before 1820, most of the people are believed that the people are the scientists whoever believed that there is no interconnection between electric current and magnetism. But in the year of 1820, so Hans Christian Ørsted conducted an experiment. This experiment is one of the greatest experiment in the science. One of the leading scientists of 19th century played a crucial role in understanding electromagnetism. During such lecture, so Ørsted giving so many lectures or so many lectures giving in different places, and in those time, in the year of 1820, in the month of April 1820, so Ørsted carried out an experiment that was never performed before. Right. So based on that experiment, then we believe that, and the Ørsted given one of the very important conclusion is there is an interconnection between the magnetism and the electricity. Before 1820, believed that there is no interconnection between electric current and magnetism. So Hans Christian Ørsted conducted an experiment. So he conducted an experiment, a simple experiment he conducted. So he conducted an experiment. He placed a compass needle underneath a wire which is carrying electric current. So he conducted an experiment with a magnetic compass and a current carrying conductor, a wire which is passed the electricity. So in his experiment, when he placed a magnetic compass, underneath a current carrying conductor, we all well known that when we bring a magnet near the magnetic compass, we observe that there is a deflection in the magnetic compass needle. So we know that, but why the magnetic compass needle shows a little deflection when it is placed underneath the current carrying conductor or current carrying wire? So it shows some deflection. Generally, when does the magnetic compass show the near. But when you place the magnetic compass near or underneath the current carrying conductor, the magnetic compass shows some deflection because the current carrying conductor create or generate a magnetic field around it. Such effect of electric current. That effect of electric current is nothing but magnetic effect of electric current. Simply we can call electromagnetism. So this observation shows that electricity and magnetism were related phenomena. Sometimes some scientists influenced by this experiment continue to work the modern field of electromagnetism. Their research results in several new scientific theories and various vital inventions like a dynamo, electric motor, new technology proposed, leading to the inventions such as radio, television, fiber optic, etc. Because of Hans Christian Ørsted experiment. So this is a very simple experiment, right? So make an electric circuit, place the magnetic compass underneath the current carrying conductor, switch on the key, observe that magnetic compass means a needle in a magnetic needle in a magnetic compass shows the deflection. Before the Ørsted experiment, so we believe that those days earlier believed that there is no relation between the electric current and the magnetism. So after the Ørsted experiment, so many inventions invented. So because of the Ørsted experiment, through the Ørsted experiment, so we can understand that there is a relation, there is interconnection between the electric current and magnetism. Electricity and magnetism. Right? So this is about introduction to magnetic effect of electric current. So Hans Christian Ørsted. Right. So magnetic effect of electric current means that an electric current flowing through a wire. Magnetic effect of electric current means an electric current flowing through a wire produces a magnetic field around it. Produces a magnetic field around it. Magnetic field is produced around it. Is called magnetic effect. Magnetic effect of electric current. Magnetic effect of electric current. Right? In other words, electric current produce magnetism. Electric current produce magnetism. That's why I have told you the other name of this chapter is electromagnetism. Magnetism is produced because of electric current. Right? So with help of Hans-Christian Oersted experiment. So we concluded that there is, and we understood that there is a interconnection or there is a connection between the electric current and magnetism. Between electric current and magnetism. Now let us understand about magnetic field. Let us understand about magnetic field. So these are some effects of electric current, heating effect, chemical effects, magnetic effect. So the magnetic effects of electric current we can call as electromagnetism, and Hans-Christian Oersted experiment, a simple experiment we also conduct in a lab or in our home also. It is available cell battery, connecting wires and magnetic compass. So we can also understand. So in class 7 or class 8 you understand doing the chemical effects of electric current. Some cases we have to use magnetic compass in a circuit or in an electric test. So let us discuss next magnetic field. Magnetic field. Let us understand what is meant by the magnetic field. Magnetic field. Before that, let us understand what is meant by field. What is meant by a field? Even in class 8, first chapter, force and pressure. Force and pressure in old textbook, not in new textbook. So you understand that what is field. So what is field? So next topic, magnetic field. Magnetic field. Before that, let's understand what is meant by a field. It is meant by a field. For example, let us know the term meaning field. What is a field? Field is the region. Field is a region. The region field. Field is the region in which or field region or a place in which the object field is the region where in which field is the region the object shows its effect on other object. Field is the region where the object shows which the object shows its effect on the other object. So simply we have to show our effect within the particular place only. So that particular place we can call as the field. So for example, we have to do many activities in our home, right? Whatever we want to do, we have to do in our home. If you want to dance, we have to do. If you want to cry, we have to do. If you want to sing a song, we have to do. So whatever we want to do, we are able to do in our home, because home is the place or the region where we have to show our effect. We have to show our ability. We have to show our strength, we have to show our attitude, we have to show our some other whatever, right? So home is the place where you have to show your affect on your parents, on your siblings or any other persons in the home. Once we have to come out, once we have to step out from home, what will happen? We cannot show our attitude. If we show our attitude outside, then what will happen? Something is happening. So home is the place or the region where we have to show our effort. Similarly, everybody shows its effect. For example, a person want to bet the other person up to the arm distance only. Arm distance lo evaraina unte we are able to hit them, we are able to bet them. So surrounding arm distance we are able to hit the person. Similarly, a magnet also shows its effect in a particular region only. That particular region we can call as magnetic effect. Simple చెప్పాలి అంటే మన యొక్క ప్రభావము లేకపోతే మన యొక్క బల్బు లేదంటే యాటిట్యూడ్ చూపించాలి, మన యాంగర్ చూపించాలి అని అంటే అది కొంత ప్రదేశంలో మాత్రమే చూపించలేదు, మిగిలినటువంటి ప్రదేశాలలో మనం చూపించలేదు. మన కోపం వచ్చింది ఇంట్లో కనుక ఏ వస్తువు ఉంటే ఆ వస్తువు ఎవరి మీద ఉంటే వాళ్ళకి అడగలేదు. అదే మనం ఒకసారి బయటకు వచ్చిన తర్వాత మన కోపం వస్తే ఏం చేస్తాం? ఏం చేయలేము. జనరల్గా ఏమవుతుంది, ఏం చేయకుండా సైలెంట్గా వచ్చేస్తాం. ఎందుకు? అది మన ప్లేస్ కాదు కదా. సో ఫర్ ఎగ్జాంపుల్ మన ఊళ్ళో ఉన్నాం అనుకోండి, మన ఊళ్ళో మనం ఏమైనా చేయొచ్చు, ఎందుకంటే అంత సపోర్ట్ ఉంటుంది. మన సొంత విలేజ్ అనుకుంటాం, సొంత టౌన్ అనుకుంటాం, లేదా సొంత లోకల్ అనుకుంటాం, వాట్ ఎవర్, రైట్? సో విత్ ఇన్ ద లోకల్ రీజియన్లో, విత్ ఇన్ అవర్ ప్లేస్లో మనం ఏం చేయాలంటే చేయలేదు. అదే మనము ఫర్ ఎగ్జాంపుల్ నంద్యాల అనుకున్నాం, నంద్యాల దాటి ఇప్పుడు డిస్ట్రిక్ట్ వెళ్ళామనుకోండి, అక్కడ మనం ఏం చేయలేము. మనకి ఎంత కోపం వచ్చినా సరే, ఏం వచ్చినా సరే. అలాగే అదర్ ప్లేస్లో ఉన్న వాళ్ళు మన దగ్గరికి వచ్చిన వాళ్ళు ఏం చేయాలి? వై వీ హ్యావ్ టు షో అవర్ ఎఫెక్ట్ ఇన్ ఏ పర్టికులర్ రీజియన్ ఉంటుంది. సో దట్ పర్టికులర్ రీజియన్ వీ కెన్ కాల్ యాజ్ అ ఫీల్డ్. Generally, the term field related to the crops or agriculture. So somebody shows that from here to there, where the last tree is appearing. So around our field only. So ఇక్కడ నుంచి లాస్ట్ చెట్టు వరకు లేదా పూలు వరకు కనిపించేదంతా మన ఫీల్డే. ఎందుకు? అదంతా మనదే. ఆ తర్వాత మనది ఆ రీజియన్లో మాత్రమే మనం ఏమైనా చేసుకోవచ్చు. ఇల్లు కట్టించుకోవచ్చు, ఫ్యాక్టరీ కట్టించుకోవచ్చు, పంటలు పండించవచ్చు, లేకపోతే ట్రీస్ పెంచుకోవచ్చు, మనకి కావాలంటే చేసుకోవచ్చు. సో ఫీల్డ్ ఇస్ ద రీజియన్ వేర్ ద ఆబ్జెక్ట్ షోస్ ఇట్స్ ఎఫెక్ట్ ఆన్ ద అదర్ ఆబ్జెక్ట్. సిమిలర్లీ here we place a magnet, a bar magnet. We know bar magnets, different kinds of magnets are there. Horseshoe magnet, the U-shaped magnets, bar magnets, then right, different types of magnets we know. So when you place a bar magnet here, so and we sprinkle or we place some other magnets or any magnetic substances like iron in different places. So the magnet attracts or shows the magnetic effect here, magnet or any other magnetic substance like iron nails or iron filling, it shows it effect within this region. Within this region. After the region, if you place the object here, this magnet doesn't show effect. So because this object is out of its region, so the region where the magnet shows effect on the magnetic substance or the other magnet, we can call as magnetic field. Magnetic field. So we know a magnet has two poles, south pole, north pole. South pole of two magnets repel each other. North pole of two magnets repel each other. One north pole, one south pole attract each other. We already know, these all are know. So that's why no need to explain much about magnetic poles, magnetic properties. Right? So magnetic place, magnetic field, the space surrounding a magnet. The space surrounding a magnet. The space surrounding a magnet in which magnetic force is exerted is called magnetic field. Means within this region or within this surrounding. So the space surrounding a magnet in which magnetic force is exerted, magnetic force is acts, magnetic force is applied, or magnetic force is exerted, that region, the space, surrounding place, you can call as magnetic field. Within the field only, the magnet shows its magnetic force. The magnet exerts its magnetic force on another magnet or any another magnetic substances like iron, nickel, chromium, etc. Right? So the magnetic field has both magnitude as well direction. The magnetic field has both magnitude as well direction. The direction of magnetic field. The direction of a magnetic field at a point is the direction of the resultant force acting on a hypothetical north pole placed at the point. The direction of a magnetic field at a point is the direction of the resultant force acting on a hypothetical north pole placed at the point. So this is the direction, hypothetical. So let us represent the magnetic field with magnetic field lines. What are these magnetic field lines? Right, a magnetic field is described by drawing a magnetic field lines. We can represent a magnetic field with the help of a magnetic field lines. When a small north magnetic pole is placed in the magnetic field created by a magnet, it will experience a force. and if the north pole is free, it will move under the influence of magnetic field. So the path traced by a north magnetic pole free to move under the influence of magnetic field is called magnetic field. So in other words, the magnetic field lines are the lines. The magnetic field lines are the lines drawn in a magnetic field, drawn in a magnetic field, along which a north magnetic pole, along which a north magnetic pole would move. So simply the lines which represents the magnetic field, the lines which represents the magnetic field is called as magnetic field lines. Magnetic field lines. Simply we can say that. We can represent the magnetic field in terms of lines. Okay. Magnetic field lines. The magnetic field lines always emerges from north pole of magnet and merge at the south pole of magnet. So magnetic field lines are emerge out from north pole and merge into the south pole. Emerge out from the north pole and merge into the south pole. So north pole, south pole and south pole. So these are the magnetic field lines. These are the magnetic field lines. So here also represents lines. So this is the representation of magnetic field. Around magnetic field around the magnet. So starts from north pole and emerges from north pole and merge into the south pole. Start from north pole and emerge from the north pole and merge into the south. In this way, we can represent the magnetic field lines. To represent the magnetic field or magnetic field lines, we have two simple experiments. So, representation of field are showing magnetic field. By using magnetic compass, and second one by using iron fillets. By using iron fillets and by using magnetic compass, we can shows or we can represent magnetic field. can show or we can represent the magnetic field. In what way we have to show the magnetic field? By using magnetic compass and by using iron fillings. Using iron fillings. So bar magnet, in case of bar magnet. So by using iron fillings, simply a table, spread a white sheet on the table and place a bar magnet on the paper, then sprinkle some iron fillings or iron filling around the magnet, and when gently strike on the table, so the iron fillings are arranged or forms a pattern around the bar magnet, so that different pattern which are formed by iron fillings represents the magnetic field, of bar magnet. So it shows like this. So it gives a different pattern. Around the magnet. It shows a different pattern. So this pattern you can known as magnetic field. So spread a sheet on a table, place bar magnet in the middle of the paper, sprinkle some iron fillings around the magnet, gently strike on the table while we are striking. So iron fillings are arranged in a different pattern or in a particular pattern around the bar magnet. So that different pattern shows the magnetic field of a bar magnet. This is by using iron fillings. Then how can we represent magnetic field with help of magnetic compass. Right? So a compass consists of a tiny pivoted magnet, usually in the form of a pointer, which can turn freely in a horizontal plane, and it is enclosed with a non-magnetic metal case having a glass top. We have already seen the magnetic compass. We observed that a magnetic needle inside it, so which is freely moves in a horizontal plane. Right? The tiny magnet of the compass is called magnetic needle, or simply we can call as needle. So the ends of the compass needle point approximately towards the north and south directions. Actually, the tip of compass needle points towards the north direction, whereas its tail points in the south direction. We don't know much about it. So here, how do we show magnetic field by using the magnetic compass? So on a table, we place a bar magnet as per the paper. So we can place the bar magnet like this, and we place take a bar magnet. A floating compass is now brought near the north pole of bar magnet. In this position, the north pole magnet repels mark the position of the tip, tail compass B and AB and okay. So on a table or spread a paper, place a bar magnet and place a magnetic compass here in front of the North Pole. So due to North Pole it shows some deflection. So the head shows deflection, the tail. So here you can denote a point A. So then place the compass at the point A and show some direction B, and place compass at B, show some deflection at C. So means the direction of the magnetic compass in which direction the magnetic needle shows, in those directions we have to plot some points like A, B, C, D. Okay, A, B, C, D. So similarly we can we get lattice. So whenever we join all the points, we get lattice. Then to place the other place, we get lattice. So similarly, the other side, we get lattice. We get this type of pattern. We get this type of pattern. So we get this type of pattern. So with a simple explanation, you cannot understand. So by doing the activity or by doing the experiment, you can understand well. But here I am telling you, so take a bar magnet, place on the table, spread a paper and place a magnet on the paper. Now place a magnetic compass near the North Pole. Then due to magnetic field or due to magnetic force, some deflection happened. So in which direction the head of the magnetic compass, magnetic needle shows, along the direction will we change the position or place the magnetic compass in the particular direction. So it shows different direction in different points. So whenever all the points are joined together, then we get this kind of pattern around the magnet, around the bar magnet. So in intermediate we have to do this activity to know the magnetic field lines, right? So the magnetic field lines leave the north pole of magnet and enter its south pole. The magnetic field, I already told you, the magnetic field lines are emerged out from the north pole and merge into the south pole, or the magnetic field lines are leave the north pole and enter into the south pole. The strength of magnetic field indicated by is indicated by the degree of closeness of the field lines. Where the field lines are closest together, the magnetic field is strongest. So this is one of the magnetic field line. This is another magnetic field line, and this is the another magnetic field line. This is the other magnetic field line. This is the other magnetic field line. This is the other magnetic field line. Similarly, this is the magnetic field line. 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 So in the magnetic field lines, if the magnetic field lines are very close to each other, then the magnetic field strength is more. It has more magnetic field strength. The magnetic field and magnetic field lines of force exist all the planes around the magnet. So magnetic field lines are formed like this in case of our magnet. So just like it is also appearing like this only. Whenever all are combined like this, all are can represent the magnetic field. You can represent the magnetic field. So magnetic field, the space surrounding a magnet in which magnetic force is exerted is called magnetic field. So it has both magnitude as well as direction. Magnetic field is represented in magnetic field line. So these magnetic field lines are emerge or from the north pole of magnet and emerge or match or enter in the south pole. You can represent the magnetic field by using magnetic compass and by using the iron filings. So this one is understand very easy, but by using magnetic compass, while you perform the activity, while you do the experiment, then you can understand how these magnetic field lines are formed electrically. So you can understand by using the magnetic compass. Here I will show you how these are formed. So let's see. This picture shows the magnetic field patterns of bar magnet as traced by iron filling. The black lines in the above picture consist of iron fillings lying along the magnetic field lines of the bar magnet. Right? This is the one process by picture. Then the other one I will show you. Let us see. So plotting compass shows the head of magnetic compass with arrow mark placed at point A, B, C, D, E, F, G, H, I, J, K, L entered. Then again the downside A dash, B dash, C dash, D dash, F dash, F dash. So similarly we get some magnetic field line obtained by joining various positions of north pole of plotting compass. So finally we get this kind of field structure, magnetic field lines, right? So this is about the magnetic field. Then what are the properties of magnetic field lines? Properties are characteristics of magnetic field lines. The magnetic field lines emerge from the magnetic field lines emerge from north pole. Emerge from north means leaves from north pole and merge to south. Merge at its south. The magnetic field lines comes closer to one another near the poles of a magnet, but they are widely separated at other places. So near the poles they are very close to each other. In other places they are move away. The magnetic field lines do not intersect with each other. So these magnetic field lines do not intersect with each other. So magnetic field lines are emerge from the north pole of a magnet and merge at its south pole. So magnetic field lines are very close at the poles, away from the other places, and the magnetic field lines do not intersect, do not cross one another. This is due to fact that, right? So these are the properties and about the magnetic field. This is about the magnetic field. So I hope understand. So please read the textbook and know what are bar magnets, what are compass, these are all those things you are able to understand. Thank you.